My testing 1, 2, 3. Testing 1, 2, 3. 1, 2, 3. Okay, let's go into last week. We stopped at this example, correct? Now we go into example number 2. Now we have a case where a bullet was shot into the water. A small projectile fire vertically downwards, go down with an initial velocity of 60 meters per second. You're given one information here, which is an initial velocity, which is V O or V O or V. Oh, sorry, V O. Due to drag resistance, the float projectile experienced a deceleration. Last lecture, we already tell you what I mean by positive A and negative A. What I mean by when your acceleration has positive, your acceleration has negative. So you have a deceleration A negative 0.4 V cube meter over second square, where V is in meter per second. You need to determine the velocity and position after it is fired. Right. Now, just to recap, for your assessment, your question consists of 3 sections. Let's say you have 25 marks. Section A will be definition or free body diagram. If you don't sure what is free body diagram, go back to your static and study again. Second one is your calculation in your section B. C is your answering how, what, usually related to motion, whether it move to the right, continue to move, or stop at a certain time or certain condition. So these are the 3 structures. So how do we solve? First, it's important you know the coordinate system. Where is positive, where is negative. In this case, going down is positive. Just now, before the class, we mentioned to the right is positive, going up positive. However, in this scenario, because I want to avoid all the negative sign in my calculation, my motion is going down, so I'm going along my motion. My motion is going down, so going down is positive. So in the diagram, I draw this line. I can represent my bullet with particles. In this module, you study particles and rigid body. Your test 1 will be everything about particles. Test 2 will be everything about rigid body. Your final will be both. So you go down, coordinate system, we set go down positive. Velocity was given. What is the initial velocity? 60. Acceleration also given. Definition of acceleration is the change of velocity divided, not divided, differentiate with time. So you are given this acceleration, you need to find velocity. So call the acceleration definition dv over dt. Next one, you move dt to the left-hand side, hold the dv, you'll get a linear form. And in mathematics step, you have d something one side, d something one side, automatic next step will be integration. In this module, automatic one, in this module have a habit of when you see d something, next step will be integrate, right? And in question example 1 will already tell you what is the area of error, why you cannot integrate V directly, and so on. So A acceleration, you are given minus 0.4 V cubed. So you rewrite the equation, you get dV equal to minus 4 V cubed dt. And in chapter 1, I mentioned also sometimes I purposely give you wrong answer. And you need to fix my slides. Huh? Correct, huh? Okay. So what is the next steps? When you do this one? This one? This one correct or not? This one correct or not? Correct, huh? What is the A? Even not? Minus V. So this one move here. A dt dv. You get this equation correct? Correct. Yes. This one is A. dv equal to A dt. Okay. So yeah. So this is yeah. Okay. So this is A dt. No. Okay. Your A is this one is A, right? This is A, right? So you just substitute this one in. Correct. So because your A is this one. So you just move this one to here. Then you do. Okay, next step. When you do integration or differentiation, make sure you differentiate the same term. This is V, so you cannot integrate V. You can only integrate or differentiate T. So this is V, put the V in the same side. Put this one to same side. It's 1 over something. Equal to dt. Next step is integrate. Okay. I will skip all the integration steps very fast. I assume you already know. So here, when you integrate, remember that you have a limit there. In example 1, your velocity or your acceleration or time start from 0. And start from example 2, you no longer see your starting point is 0. So here, your velocity is 60. Because it gives you initial velocity 60 to the velocity you need to find. And this one is time. You integrate time. Remember, dt in front is 1 and not 0. Because some students, when they come to final exam, I don't know, somehow their brain trick them. They will write this one 0. They will automatic, I don't know, somehow. They will write this one 0. So answer wrong. So 1 over V. My step is I always pull the constant out first. So I get 1 and negative sign outside, and I integrate 1 over V cubed. I don't like fraction. I write in linear form or exponential. 1 over V power 3 in exponential. Nico, what is the term? How do you write? How do you write? 1 over V3 equal to V what? Nico, what is your answer? Your answer is 1/3? One over V3 equal to V power what? What is your X? Huh? 1 over 3? 1 over 3 or minus? Which one? Huh? Power minus 3. What does 1 over 3 mean? What's the V 1 over 3 mean? If you don't know, you need to go back to your mathematics class already. This is cube root. Okay, so next steps will be I change this one to v minus 3, 1. Why I write in exponential form rather than fraction? Because this one will help me when I do my integration. Okay, this one, if you are good, then you can continue. But I usually write in the linear form or write in the exponential form. This one, when you integrate v power negative 3, you integrate plus 1 divided by n plus 1. So this one become half v, negative half v power, get this one, get v power negative 2 divided by negative 2, substitute from v to 60. This side, you get t minus 0. Okay, so all this you need to show in your solution when it comes to test or final exam. You need to show all these steps. Okay, then from there you get a quadratic equation. You solve for v. You write the v, continue write. This one put to here, continue to write, put this one to the left. Make sense? Nico, make sense to you? Then your v equal to, you pull this one to the right, you get minus 1 over 2. Okay. So this is a square root question, but with a negative, which is 1 over something. This is the first equation you get from this one, but it asks you to solve after 4 seconds. Nico, find what is the velocity after 4 seconds? You also try to find what is the answer after 4 seconds? So what is the answer? 0.559. What is the unit? Per second. All right. You get the same answer? For this module, minimum you need to give me 2 decimal place, maximum 3 decimal place. And plus the unit. So if you miss the unit, automatic discount 50% from the marks. Magnitude and unit. So let's say you forget to give me answer. This is, let's say, 4 marks. You automatic miss 2 marks in your solution. What do you get? This one. Okay, answer is 0.559 meter per second. What is the position? How do you solve this question? Now, by giving the definition over here, you have the velocity equal to differentiate of your displacement. Acceleration, you can use velocity equation and the displacement. So what you have here, you already have the velocity equation. So Can you do calculation? Okay. Velocity value is positive, so it continue to go down, right? Velocity, you have, then you need to find the position. Acceleration equal to dv dt. So you have this velocity equation just now from section A or from the previous one. So this equal to ds dt. So you rewrite this equation and this equation the same form. You do rearrangement, then you do integration. You get the s, right? You get the s. ds equal to this one. ds one side, dt one side. The next is integration. But you need to check. In fund integration, if it's not in terms of t, then you cannot now. You need to change in the same term. Okay. You continue to do integration. Okay, what is the answer for displacement after 4 seconds? You do integration. So this one, you do integration, substitute, your s will be in this form. Okay. When t equal to 4, you substitute value there. Okay, substitute value there. Value is 4.43 meter. Okay, now go home and polish your integration and differentiation skill. Right? Okay. So sometimes it's not that you don't understand. Sometimes it's not that you don't understand the question. You start at the integration and differentiation steps. Okay, go and polish. All right. What is our assumption? Just now early, we assume go down is positive, right? Positive. Okay, what is our general coordinate system we set? For the whole system, go down is negative or positive? Yeah, this bullet go down, right? We set go down positive or negative? So all the value you get positive, it means is follow your assumption. Everything is positive. Go down is positive. For this example. No, since the beginning already assume go down is positive already. You understand? No. For this question only. I just flip the question. Of course, you can assume this one go up is positive. Go down negative, you can. All your working will be negative inside. You'll get negative sign here. You'll get negative, velocity also negative. Understand? But I don't want to get negative value. I flip the system. I assume go down positive. Huh? Okay. That's why in the beginning, I always told you guys to tell the coordinate first. Either move to the left is positive, move right positive, go up positive, go down negative. Location is important. Where is positive? Mark your answer. All right. Always draw your coordinate system. Where is positive? This case, I assume go down. But to analyze the problem. Okay. Next, we look at not projectile, but a rocket problem. So when it comes to final exam, sometimes you need to know how to draw the motion. So this is the final exam standard or your test 1, test 2 standard. Normally, I'll just give you one statement like this, and then I'll give you one diagram like this. You need to draw the whole process. Huh? So a rocket travels upwards 75 meters per second, and when at 40 meters from the ground, the engine failed. Does the rocket continue to move? When it fails, it's like you drive, all you're driving, right? When you drive, your engine broken. Will your car continue to move, or it will immediately stop? Huh? Continue to move, right? So in this case, it's just a catchy problem. When something fails, it will continue to move. It will stop is in the static module. When it comes to dynamics, it will continue to move. It will slow down, but it will not stop at that point. Okay? So there's a difference when you study engine dynamics. It will continue to move after 40 meters per second, but it will slow down. Determine the maximum height it reached by the rocket. What is the speed when something reach the maximum height? What is the speed? Oh, sorry, what is the velocity? 0. Make sense? Strong? Understand? Okay. So at the position maximum, your velocity is 0. So all these are untold information you can use to analyze your problem. So when in motion, subject to constant downward acceleration, it gives you one keyword there. Your acceleration is constant. It means you can use this equation. You can use equation of motion rather than this one. Of course, you get the same answer if you use this side of equation. All right? Ignore drag resistance. So first steps, you need to determine where is positive, where is negative. Go to your diagram. You can represent this object as a particles, marked as 0 for your ground. Go up is positive. Okay, go up positive at 40 meters, it failed. So first point, A is 40 meters, velocity at that time is 75. Then it slowly slow down. Okay, so you have a few parameters there. It will slow down. When it reach velocity 0, that is the maximum point. Then it will ask you to find what? The speed just before it hit the ground. So you need to find position here to here and the speed when it come down. So when it come down, before it hit the speed, hit the ground, you need to find the speed at C. So all this you need to develop in your solution when it comes to final exam, maybe in your test 1. You need to read the question, think, then draw. All these are represented by dot because it's particles. So how do you start? Always start with the coordinate system. Where is positive? Where is negative? In this case, we fix all the position going up is positive. Okay? So from ground level, go up positive. Throughout all the solution. You don't one you go up positive, then halfway you change go down at positive. Don't. You solve for one question, the whole question you set one set of coordinate system. All right, if you set go up positive, then all the question you solve in for this diagram is fixed already. You don't halfway change. You fix positive, go up, then everything go up with positive. Maximum height, you need to find the maximum height, right? You have the velocity at 75. Yeah. You have SA 40. So you have the initial height. You want to find final height. You have initial velocity. You have the final velocity. Check these three set equation of motion. Which one give you most of the information and only one parameter is missing? This one, you have this one, you have this one, you have this one, you don't have this one. But the question don't ask you time, right? Question didn't ask you time. So this one, reject. This one. You have this one, you have you have this one. Sorry, you don't have this one. You don't know the last position. You have this one. You have this one, acceleration. You also don't have time. You have more than two, reject. This one, you have velocity, n velocity. You have initial velocity. You have acceleration. You want to find your final position. You have early position. Straight away, use this equation. Make sense? So in this case, what need to be careful is your acceleration. The acceleration, the gravitational force is pulling down. So your acceleration in this case, you use negative sign because your global system or your coordinate system going up is positive. If you use positive A, what does it mean? It means your gravitational force is pulling up. This is the careless mistakes, usually in the final exam, when I ask you to solve something like this. Of course, I won't ask you rocket anymore. I will ask you something that somebody throw something up and then go down. Okay. So it's negative, understand? Okay, so in this equation, the A here is negative. When you have negative, be careful on the negative sign. Negative become positive. Okay, but this one in your solution, so you understand why we use this one. Okay, the rest is a substitution. Substitute. VB, you know, 0. VA is what? 25. 2, this one negative. This one you need to find. This one is 40. Make sense? Only one unknown. Use calculator solve. So your SB is 327 meter. You know the height of this one. Then you need to find velocity at C, right? Check again. Since go down, since the acceleration is constant in this system, check, you can use motion equation. Check this one. V, you know. This one also you know. Acceleration you know, but you are not interested in time. This one also we're not interested in time. This one we can find. This is the final velocity we need to find. Initial we know. This is where? This is what is the value? This is after, this is before, right? It's 2 points. In this case, don't use this position anymore. We use this position to this position from B to C. Yeah, because you need to find C, right? So you cannot, you are in the early slides, I show you speed and velocity, right? You are finding velocity and not speed. Speed is total divided by time. If you're finding speed, the answer is 0. Why? Total distance, you compare here and here, there's no difference of distance. Total distance 0. However, if you calculate velocity, then it's different. Velocity, you talk about vector, you want to find here to here. Okay, so velocity, we take point B and point C, substitute V, C, this is the final velocity. VB, we take B as our reference and not O here. And AC is negative because acceleration keep pulling down. Our total or overall coordinate system go out is positive. So we still use negative 9.81. SC, you know, minus SB, right? So here is 0 because it start from here, you measure from here, 0. Most students confuse this value. This is 0, minus, then only one unknown. Okay. When you square root, you know that mathematics, you square root, you get 2 roots, right? Correct? You square root your x, you get positive x and negative x. Why this case you choose negative? Going down, So there are two set of answer. You can write negative 18.1 meter per second. Then you tell the motion go down. Okay, or you can give positive magnitude, but with the motion. Two set answer. You can either give this one or this one. This is the section C solution.
Minus 80.1 dollars.
No need. Okay. Once you get negative, you should know whether it's go down or go up. Right. So once you find this one, the answer for VC is correct, negative. But the question will ask you to give or explain the motion. You still need to give the answer whether the particles or the object is moved down or moved up. But however, if you forget to explain this one, and in your free body diagram, you already give the position go up is positive, then I will still give you marks. Meaning in here, I do not give you coordinate system, right? I don't know whether go up positive, negative. But if you in the diagram there, I give this one. Means this is a particle, move up. I write this one positive, means I don't need to check for your answer. Okay, so it's important to give coordinate in your free body diagram. Since the beginning, have the habit of telling the examiner whether go up positive, go right positive, and so on. Okay, the rest you read. Today we go into last week we are in a continuous motion. Rectilinear, continuous. Today we learn erratic motion. What does it mean? It change the motion when it move. Okay. Do we need a short break? This one? Continue, Okay, our time is until. Okay, we continue, Okay. So we continue with another motion. This is called erratic, means something happened in the middle of the journey. Okay. So again, a highlight in the red color. Your position, velocity, acceleration. Your position, velocity, acceleration cannot describe using single continuous mathematical function, which is this one or this one. Okay, you need to be careful on the integration section, lower limit, upper limit. You need to be careful on here because something happened in the middle. So you need to break the motion into 1, 2, 3, and so on section. You need to look at one particular time. Okay, can I? Okay, we will use graph. For erratic motion graph, test one sure come up one, this one. Final exam, it depends. Because final exam, too many things to want to ask you already. Graph, still okay, right? So how do you convert the motion into graph? We'll introduce you 3 types of graph: position time, velocity time, acceleration time. This one I think you learn in your physics class. Right? Just need to be careful on shape of the graph. Because since it's related to graph, we have 3 types of graph in common. Linear graph, like this, y equal to mx plus c. Quadratic, y equal to ax squared plus bx plus c. You need to know what is c and so on. And polynomial, y equal to ax cubed plus b plus something. Okay. So let's start. So if you're given S and T, let's say you have this diagram. You have S and T. This is what kind of graph? Quadratic. This is a quadratic curve. So if you take these changes of slope, on graph you have slope, right? Go back to linear graph. M is a gradient, right? How to find gradient? Change of y divided by change of x, right? So you take y2 minus y1, x2 minus x1, correct? So you take the changes of y divided by changes of x, correct? In the S versus T graph, in a S versus T graph, what is your y? What is your x? What is x divided by t? You get velocity. So the slope of the graph will give you velocity. Make sense? What is VT? Velocity versus graph. Again, I give you a quadratic motion. Same, y versus x. Now your graph is V versus T. V versus T, what you get? Acceleration. No. Acceleration. And the A to T, the slope means nothing. Right? Because you take A divided by T, you get undefined. You don't know what is that. It doesn't give you any meanings. However, the area below the AT graph give you something. Okay, we will look into that. So these 3 of graph are expected in your test 1. Make sure you practice this section. Yeah? So we look at S versus T graph. So normally the question will come out like give you a certain behavior. They tell you one particle move up or move down, and then you accelerate and so on. Then you need to convert the statement into graph form. Okay, first you draw S versus T, and then you plot the graph. Right? So for example, this is a quadratic graph, right? What is the form of quadratic graph? Y equal to x squared plus bx plus c, right? Right. Means in the question of S versus T question, it will give you S, this is S, this is T, correct? Right. Correct. So your Y is S, right? So your X is what? Is T. So you'll get AT squared plus BT plus C form. Meaning in the statement, you'll see, oh, the particles move in a certain motion with a position in this equation. Let's say 3t squared plus 2t plus 2. Then you predict, you draw the axis first, then you draw based on type of the line that you learn in the mathematics. Whether it's a straight line, of course, the straight one will give you like S equal to 2t plus 3. Then you know this one is a straight line. Okay, so this is the difference between static module and dynamic module. Static, it give you one straight number. But when it comes to dynamic, you need to play with the equation. Okay, let's say you have point 1. Point 1, you have T1. And extend to the left, you get S1. So this is the gradient. We can find the gradient of this one. The gradient you know is velocity, correct? Gradient is S versus S divided by time, right? So V equal to ds dt. Or in mathematic form, in later, when you become expert already, you write V1 equal to ds dt, one line. T1 means you are looking at time 1. Okay, you apply the same lah. So from here, if you are from the S versus T graph, what you can do, you can get velocity from the graph. Okay, you can get from ST, you can get VT graph. You know, you can transform all the point on this blue line on the ST graph into velocity. Makes sense? Sense, huh? Okay. VT graph. Just now ST, now VT. VT graph also now we assume we have a velocity curve. When you look at the question, you already know whether you need to draw VT, ST, and also it'll give you a certain type of equation. Then it gives you velocity. For example, give velocity V equal to 3x squared plus 4. You know this one is a quadratic equation. And you know this is V, this is extra T1. So you need to draw this one on the VT graph with the quadratic form. Make sense? So let's say we pick point number 1 on this curve. It can be straight line, but in this case, we just give you a quadratic form. T1 and V1. What is the slope of VT? Acceleration. Gradient for VT graph, it give you acceleration. Meaning each point on the VT graph will give you AT graph. We can transform VT into AT graph. Make sense? Okay. Third one, AT graph. AT graph, let's say you have logarithm or exponential curve. You pick this point, T1, acceleration 1. We can reverse this one back to VT by using definition A equal to VT. How do we get V? How do we get V? We transform using integration. AT equal dV. You see, A dt over left hand side, U dV. you can do dt dv, you integrate, you get v. Make sense? Now, what does it mean? This is what I write on the white screen. At equal to dv. You integrate a dt equal to v. A is this one. So this is integrate a dt means at graph. A dt means area under the graph. Means this area is v. This area is v. So you find the area under the graph, you transform this one to v point, v dot. Understand? This is the red color highlight, and this is a change of velocity. Change of velocity, v1, v2, v1, v2. So here is from 0 to t1, 0 to t1 equal to this one. So on the vt graph is from v2 minus v1, correct? v2 minus v1, you get 1 point. Right? Okay. So it means from here, you know your VO, V1. It's not necessary from original. So V1, V2 from what? From this equation. From this equation. Okay. So this is delta V. What about VT? Use the same principle. Right? Use the same principle. You can change this one to S versus T graph. Sense? Use the same principle. I do it a bit faster. So again, VT graph, below the graph, it means displacement or position, right? Then this is a change of position, displacement. Huh? So you can change from VT into ST graph. And again, it's no longer, you have 2 points. Huh? You have S1 and S0. It's not necessary from origin. Huh? Be careful on that. Huh?
ST or AT graph?
TO?
No. From VT, we should change it to AT, right?
VT to?
AT graph, right?
You can. You can. What does it mean from all this graph? Or from these 3 equation here? What does it mean? There's you are playing with differentiation and integration. This one, V to A, VT to AT. What do you do? You do differentiation. AT back to VT, you do integration. But this one, you focus on area under graph. Make sense? This one, you point to point. Gradient. This is pointing gradient. Same. A to V. A downgrade to V, you do integration. Meaning, from here, this to acceleration, you differentiate. You go back, you do integration. Go back, integration. Go down, differentiate. This one, the differentiate position, you get the velocity, right? Correct? So, same. So 8S, there's one more graph, we call AS and VS. So 3 type of graph, plus 2, ST, VT, AT. plus two more graph, AS and VS. So let's say you have AS graph, S1 and A1 and A0. Can you turn this one to VS? You can, huh? You can. How? What is the common currency here? Time. This one with AS, right? You have S1. So you have A1, you have S. How you change from A to S? You do point integration or integration. We'll give you example later. Okay. Okay. The common currency is time. Just now, you still remember in chapter 1 before this, we use definition of velocity, we take the t out. The definition of acceleration, we take the t out. We put the same, meaning both graphs, we freeze at that particular time. Then we arrive at A ds over V dv. You have AS graph, you have V graph. So from here, integrate this one become what? Area under the graph. You get V, right? So S is the same. S is the same. You stay at S, you find the V. The x-axis is the same. Only you find what is a B. Because you freeze the time already. Make sense? So these two graphs, you use this equation. AS, VS, you use AS equal to V dV equation. Make sense? To convert AS graph to VS graph. You understand? I did this one. Okay. Right. I think yes. So you have this equation when you integrate. Okay. Integrate this one, you'll get what is this shape? But anyway, we will come back to this equation because it's 11 already. We have class of this. I think nobody using this class. We go a bit further. So this graph is area under graph on the left hand side. On the right hand side, you straight away use this equation. Wait, yeah, correct. Do you know how to get half? Do you know? This is integration mathematics again. A ds equal V dV, right? You integrate A ds, integrate V dV. What is the equation over here? When you integrate, what changes to the V? V power what? 1. When you integrate, become 2 divide 2. Why? Vn plus 1n plus 1. Yeah. So you integrate from V1, V2. Then from here, you get the equation on the screen here. Half V1 square minus V0 square. Makes sense? Yeah? I'll explain this one. What does this equation tell you? Okay, you can convert one. You can convert. When you convert area under graph, which means you find under the graph, it depends on the type of the line. I draw on the whiteboard here. Normally, you have two type of graph only for diploma. Straight line, what is the shape you have? Trapezium, right? What is the equation to find trapezium area? Half A plus B, then? Correct. 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 So same. Take this one, multiply this one, divide by half. This one plus this one, multiply this one, divide by half. Then you get this one. So again, how we relate time differential dt between velocity and acceleration? By this equation again. A ds equal to v dv. It depends on that particular time. We freeze the time. Freeze the time. So this is the A equal to A, you put this one, A ds equal to V dv, you pull this one over here, A equal to V dv ds. So in this case, V ds is what? Is the slope here. As you have this value, you have this value, right? So I mean, this length here is A. Then it will give you this one. Later, you look at one example, right? Can we go one more example? One more. Okay. Example 4. So let's say you have a bicycle in a straight line. Construct VT graph for t equals 0 to 30 seconds. This is a straight line. What does it mean? So it gives you one graph like this. S versus t, it gives you a curve like that. And then it gives you some numbers there. So at 10 seconds, you reach 30, but this is exponential graph. And this is a linear graph. It's a combination of two type graph. 30 seconds is reach 150 meter. So how do we convert? And you give you the slope. The slope, this one is a quadratic. It gives you 0.3 t square. It gives you one slope like this. Then it gives you s equation, s equal to 60 minus 30. This is a linear form. Correct? That's why it's called erratic. It means it's not a continuous motion. There is a change of motion along the way. So VT graph, how we transform this one to VT? We have position. You want to find velocity. What do? Differentiate. You use this one. Right. So you have a S. Okay. So information, ST graph, equation, V ds dt. So how do you find V? So we have two time slot there. 0 to 10 and 10 to 30. So first step in drawing graph, draw the axis first. So the graph want to find VT graph. So you split your graph into two. One is 10, and then S was given. 10 to 30, S was given. So you do the differentiation. V equal to ds dt. S was given, right? You want to find V because you want to plot VT graph. So you differentiate. ds dt differentiation, move 2 to the front. This one minus 1, 0.6 t. Make sense? Then this one. Okay, 0.6 t. V equal to 0.6 t. What is the form of graph? What form? Yeah, delete already. We have 3 graph, right? What is the form? Linear form. Right? Y equal to mx plus c. Your integration through 0. Make sense? Make sense or not? Can Then this one.
You need to differentiate for integrating.
Okay. Now, just now from the whiteboard, so position, velocity, acceleration. You move down from position to velocity. What do? Differentiate. From velocity to acceleration, you differentiate. Right? Then you work backwards, you integrate. Then this one, you're given S versus T. You have position. You want to do velocity. What do? Differentiate. Because you have S, you differentiate T, you get velocity. Because you have these 2 parameters, you have S and T. So you differentiate these 2, you get velocity. Then this one same. uv equal to ds dt. What do you get? 6 only, What do you mean by 6? Velocity 6, what does it mean? Straight line. Correct? X and Y. Y equal to 4. What does it mean? 4, 4, 4, 4, 4. Straight line. Correct? So this 6. We have 2 time slot. 1, 0 to 10, 10 to 30. We have 2 graph. Linear graph, straight line. Correct? With the number, with the equation, in your mind, you should already see the whole picture already. Next, what do? You have 2 equations already. You draw the 2 axes. V versus T. Cut the graph according to the time frame. We have 2 time frames, 0 to 10, 10 to 30. 0 to 10, V equal to 0.6, T plus 0, Y equal to mx plus C. Your C is 0. Correct? How to find this point? It's a straight line. You know it's a straight line. It's a linear graph. How do you know the value for this one? T equal to 10. You substitute T 10 here. You get 6 here. You stop at 6. Then the next one is what? 10 to 30. V is what? Straight line, right? You get your first graph. Okay, you get your first graph. Make sense? So it's an application of your mathematics, type of graph, and plotting graph. Linear equation, quadratic equation. Of course, you need to flip back. Lawn equation and so on. Then you move down from position to velocity, you differentiate. Move back velocity to position, you integrate, and so on. Okay. So, yeah, this one is. So the velocity from velocity you can find acceleration, right? Because you want to find acceleration graph. So velocity here, you can take. Sorry. Okay, here. Sorry. This one, the velocity, how you get 6 also? Because here you know it's 6. How you prove that it is 6? from ST graph, 150 is a slope actually. It's a slope, this slope. So y divided by x. 150 minus 30 divided by the time, 20 seconds. You get 6. There are two ways of proving your answer. One is from the equation you derived just now, or from the graph. Straight away, you can draw the line. Okay, you do the same for acceleration. So you have a VT graph. You can use VT graph. You can forget about ST. Why? Because from the early definition, S you need to differentiate 2 times. So it's no longer useful for you. You only need to do the VT. So meaning if you make mistake in VT, you are gone. The AT sure wrong. So AT, repeat the same process. You break into 2 time slot, 0 to 10, 10 to 30. Copy the equation, VT equal to 0.60 and VT equal to 6. This is the graph that you plot just now. So the next step is to draw the axis, A versus T. But you want to find AT, right? A equal to V dV. A equal to V dV, dV dt. So look at this equation, do differentiation again. So differentiation, this one become 0.6. You take out the T already. Make sense, Nico? Then this one, 6. What do you get? You differentiate constant number, what do you get? dy dx. You get y equal to 4. dy dx, what do you get? What do you mean by x? dy dx, what do you mean? You look for x, right? Okay, you can do y equal to 2x squared. dy dx, you get 4x, right? How do you get 4x? There's an x there, right? This one constant value. What do you get? There's no x there. Y equal to 4. Y equal to 4 is a number, don't have x. Don't have x, you differentiate something that don't have x, what do you get? Makes sense. This one will come out in test 1. Okay, you differentiate something without the term, means if the equation, in this case, A equal to dv dt, there's no time there. You integrate, or sorry, not integrate, you differentiate to that term. There's no term there, straight away becomes 0. There's nothing change, or there's nothing for you to differentiate, right? If you integrate, then different. Integrate, you add. Differentiate, you minus. There's nothing there for you to do about the differentiation. So 0. So you have 2 equations. One is constant, one is constant. One is 0, one is 0.6. So you draw the line. From 10 to 0 to 10, you get 0.6. Then 10 to 30. Is there any acceleration? No, 0. What does it mean? In early chapter or early session, if there's no change of velocity here and here same, right? When there's same velocity, what happened to acceleration? 0. No acceleration. Same answer here. No acceleration. So 0. Okay. So you can draw a line here, or you can just leave it blank. Also can. Makes sense. Makes sense. Okay. We continue. Next lecture is when again? Friday. Okay, no Friday, Wednesday. See you guys on Wednesday.